first to introduce Joe, please.
Okay. So we've been joined by another one of my colleagues from the Solar System Exploration Research Virtual Institute. This is Joe Manafra. And so you're getting kind of both ends of the spectrum here from the science standpoint and the engineering standpoint. Joe does a lot of work with robotics. He especially does a lot of work with student robotics. Has been the judge in a number of student robotics competitions, and is actually famous around the world and travels around the world to do these robotics endeavors. So we're very lucky to have both Joe and Yvonne with us today.
Hello, NASA, family and friends. Hello, Mr. Joe and Mr. Brian. I am part of the Atom Science Club, and I am here to present. My name is Joshua Ferri, and I am here to present our exploration zone on Mars, our landing site, aspects of water, and aspects of elevation. Okay. Mr. Brian Day, could you please drop a pin at longitude 23.5 and latitude 41.0. Thank you. Could we please put a 200-kilometer square around this point?
As Brian's doing that, I'll tell you that the exploration zone is 200 kilometers wide. We don't have a circle. There's not an ability to make a circle. The exploration zone will be a circle. So instead, we're going to go ahead and use a box, and you can imagine a circle within a box.
So it's 23.5, read to me again.
23.5 and 41.0.
So drop a pin there.
Yes, thank you.
Now we'll zoom out a little bit. Does this look approximately the right area?
Yeah.
Okay.
That I am now concluded discussing exploration zone, and I will talk about our landing site. Please drop a pin at 22.
Okay.
22.5. This is longitude.
Okay.
And latitude 41.0. Thank you. This area is called Deuteronomus Collis, and it is very flat. As we see on this poster board, it is this flat. No, I put it up right. You can imagine walking on the beach at Half Moon Bay. That's how flat our landing site is. And this is very important for safety of our landing.
So I would like to introduce really quickly, because I like having science be a family event. That's why I brought all of you into this. Josh has a grandpa who is retired, so he has free time. Where are you? Okay, stand up just for a second. Because he's worked very hard in terms of helping Josh. Josh is doing most of this part of the the presentation, because the other kids did the other things. No, others were just doing this. But go ahead, Harry. Just quickly give them your credentials.
Well, my name is Harry Sharp, Joshua's grandfather. My major part of my help with this was just helping Joshua get around on the surface of Mars. And I'm so happy that you designed this Mars trek, Brian, with latitude and longitude. It helps us get around so much easier than anything else we can imagine. My background is in navigating in latitude and longitude. The Navy here, the squadrons here at Moffett Field, and later on at Delta Air Force. makes life so much easier if you could just resort to a few numbers to get you to the exact spot on the Earth surface, or in this case, Mars surface. I've been retired for a while, so I've been out of the latitude and longitude business for 13 years. But it's so nice to be back working with it. Thanks for developing what you did.
Thank you so much.
And I really appreciate it, and I learned from Harry, because when he came and he brought this here, I said, no, you've got to do this. You guys have to make this graph. It is how flat? Did you say that? It's as flat as
It is flat as if you were walking on the beach at Half Moon Bay.
That's how flat, and that's what Harry was saying, exactly how flat some of these places are. So it felt good to calculate. Okay, go ahead.
Now, I have concluded talking about landing site, and I will talk about aspects of water on Mars. Water is both a science ROI and a resource ROI. Did you know that there are glaciers on Mars? As we see here and right here coming through the rocks and the edge of this, there was a Rampart crater. This soft, pillowy looking glacier is rolling through the countryside of Mars. We can reference NASA astrobiologist Chris McKay and his work in the Antarctic glaciers with life living deep beneath them. And Brian Day as well worked on up at Mount Lassen with pink snow, which is a type of algae encrusted in snow. And we have a couple pictures for you today, if you would put them up.
Sure.
Remembering, where there is H2O on Earth, there's life. So now we know these
And
glaciers.
isn't it amazing to think about how everywhere we find glaciers on Earth, there's life. So couldn't this mean the same for Mars? And that's our ultimate goal in going to Mars, to find life.
So here you can see kind of a red stain in the snow. People oftentimes call this watermelon snow, but it's actually a actual life form, an algae called Chlamydomonas nivalis. And if you look at it closely, it's got this red pigment in it. That red pigment actually prevents it or protects it from the harsh ultraviolet radiation of high altitude. And there's, we introduced you in the back there, Chris McKay.
Oh
and he has done so much of the leading work that you've heard about and that you have been reading about in the Antarctic, and looking at the types of life forms that can actually live in the snow. And so everybody, this is a great opportunity for you to meet one of the leaders of the field, Dr. Chris McKay.
Were you here? Did you hear him talk about you?
No, Yvonne came and grabbed me.
So yeah, this is your guy.
On a dull proposal. I'm happy to be able to come by and say hi and welcome you all to AIM.
Wow.
Exciting to hear that you're looking at these kind of.
Thank you.
Right? As long as you want, or you can. Yeah.
Yeah, so,
As Alex was talking earlier, there are Rampart craters on Mars. In fact, there are 12 in our exploration zone, and these are possible past signs of life. Water is also a resource ROI. It can be used as a drinking source for our astronauts, as well as used to make methane and O2. Methane can be used as a fuel source, and O2 obviously used as breathing for our astronauts. I'm now finished talking about aspects of water, and I will talk about aspects of elevation on Mars. Our exploration zone averages 3,300 meters below sea level. This shows up, yes, if we go to color hill shade, this shows up as blue and cyan on the color hill shade. This is very flat. Here are some of the benefits of low elevation. Landing parachutes work better at low elevation because of the denser atmosphere. It's higher temperatures, higher pressure, which is good for our astronauts, what they're used to here on Earth. Reduced solar radiation, and drone propellers work better at lower elevation. Thank you, NASA, and thank you, Mr. Brian Day, Miss Joe, and Miss Yvonne, and thank you so much, Chris McKay, for coming out here.